All right, welcome back, everyone. In this session, we'll be talking about a point being dilated from the y-axis again. This is the second videos, and over here the question says, is it find the dilated point if the point 1 comma 4, which is over here, is dilated from the y-axis by a factor of 3. Well, what does the 3 mean? Is the 3 is the k that we were talking about in the earlier videos. So let me note it down what we know. Okay. So we know that k is going to be 3, and the point with which we're dilating is equals to the old point x, the big X, which if we write in vector form would be 1 comma 4, which is here. That's 1, 4. Now, and again, we are dilating it from the y-axis, so we'll be only the x will change, and the rules which allows us to change is as follow: x, y goes to kx comma y. So the x changes to kx, the y remain the same. What that means is we move along the along the x parallel to the x axis, and we're changing the x value while keeping the y constant, right? So if we do that, let me write on the point we got. The point is 1 comma 4. That will become k in this case is 3 times x is going to be 1 comma y in this case is 4, so as it is, and this is equals to, we got that equals to 3 comma 4. All right, so the new point would be at the point, this is 3, 4. This is the original point, so this is the original. I don't even know how to spell original. And the red is the dilated point, or the new point. So here again, we're just moving along the y, parallel to the x-axis, moving away from the y-axis. So thereby only changing the value of x, keeping the y constant. We're moving a factor of 3 from the y, so the new point becomes 3, 4. Let's do this in terms of the the transformation matrix. We know that from the previous video. If you haven't watched it, please do so to get a better understanding. Nevertheless, I will just restate it here. T would be equals to brackets k 0, 0, 1, and that will get transformed into k in this case was 5, sorry, not 5, 3, 0, 0, 1, and then we know that the new point, which I'm going to label x dash, which represent the new x and the new y, would be equals to t times the old x, which is t is equals to 3, 0, 0, 1. The old x, which is here, the old point, is equals to 1, 4. If we expand this thing out, we'll get the following. So let's expand this. I'll just continue here. So 3 times 1 plus 0 by 4. So we're going along horizontal and then vertical. Then we will do 0. The 0 is from here, times it by 1, and 1 plus 1 times it by 4. 0 times 1, 1 times 4, and the new point that we obtain would be that 3 times 1 is 3, 0 times 4 is 0, 0 times 1 is 0, 1 times 4 is 4. Therefore, the new point x dash y dash becomes 3/4, as we have expected from this transformation. We do reach to the same new point. This is using the general rules, and then this is using the transformation approach. All right. I hope you enjoy that discussion and how we obtain the new point. In the following videos, we'll go on and talk about the dilation factors using Desmos, and you will get a much better understanding when you see how those points changes depending on the value of k's and what factors affect those points, and how does the point changes depending on the value of k. How fast do they move, or is it possible to have k being a negative value? And we'll do some more experimentation as well along the way. Right, stay tuned.